Yes, I'm not going to say the whole story. I'm just going to add to Eric's story because the context was set by Eric, and this very wide-ranging outlooks of the world energy consumption is, I think, more or less out there. So let me home into our sky scenario. And Eric started actually off that he made exploratory scenarios, and he was one backcast, basically. We call it normative, right? Basically what you ought to have done 10 years ago. The sky scenario is also a normative scenario, but not a backcast. So we still have the principles. We start from today. We have the asset base of today. There's momentum in that asset base. The FIDs are taken, and it'll take a while before actually new decisions will change the system over time. So, although this scenario is normative, all right, we still think it's technically doable. There's a big model behind it, right, to test it all, and we think it's economically affordable. And that is something completely different than the lowest cost, which is a political problem to start off with, right? It's an affordable scenario, and people have to really sign up to that. The other thing I'd like to say is that this is one of the scenarios we use for our strategic plan. It's become a more and more important scenario because our shareholders, especially the ESG concerned shareholders, they very much want to know, right, what are we going to do with the energy transition? Are we part of the problem or part of the solution? And they worry about all kinds of things. So this scenario is then, in that sense, also very important there. And it is actually part of the resilience testing of our own Aspire portfolio. So our company has embraced the energy transition for more than a decade, even maybe slightly longer, and it wants to thrive in that energy system. But how do you thrive when all this uncertainty goes on? Because you can be too early, you can be too late. Actually, my company has a few examples being too early. We started the hydrogen system 20 years too early. We were 20 years too early with CCS, so we only have one plant, the Quest plant in British Columbia. So it's all very well to have this vision, the scenarios, and you can get a couple of billion from your CEO to do something, but then actually there's a societal momentum which doesn't give you that license to operate. And that societal license to operate becomes more and more important while you go forward. And that's not straightforward. Well, right, this is our American lawyers who say we don't know the future either. Just to reassure you that everything I say is basically coming from my imagination, I guess. Let's just have a look at the CO2 projections of this world in our scenario. Right, so basically it needs to peak by about before 2030. So actually that's 10 years from now. And actually, how actually can we do that? And here this, let me see this. But anyway, this is the developed world, North America, Europe, and Asia Pacific developed, and you see that actually we're already decarbonizing. It's a normal economic process, of more efficient stuff, right, doing things differently with renewables, and that's well on its way. And that's 1.25 billion people in this world, having about 45% of GDP. And then you have this 5.8 billion coming afterwards, which is called the non-OECD, soon to be 7.8 billion, who would like our lifestyle. Now, I don't know if anyone has any clue what it means, but North Americans use about 300 gigajoules per capita per year. Europeans, I think with a similar good lifestyle, used half. We project China to do, again, with half of that of Europe, 70. And actually we think that the emerging economies are going to do leapfrogging as well and going for the best technology. Now, how likely is that, you could argue? Well, that is just taking the waste out of the system. So all the stuff we just heat out of the chimney, if you just get rid of that, right, you could go to something like 70 gigajoules on average. But we made it in our scenario 100 gigajoules, primary energy. So it's easy, 10 billion people times 100 is 1,000 exajoules. So then that's the way it is, round numbers. But I just like to, coming back here, China, the red. This is what you do when you outsource your manufacturing base. Within 10 years, almost a tripling of CO2 emissions globally because it was actually done by coal-fired power stations. So although we have a good feeling that, we reduced our CO2, actually we outsourced our CO2 by China becoming the manufacturing base of this world. And here's a kind of a geopolitical factor, right? If you want to bring investments to another country, that's great for their development, but you're not in control of the CO2 emissions. Then the orange is India. And they're both about 1.3 billion people, roughly. But you see, they're going to leapfrog. They're not, in this scenario, going to make the same mistakes as China's doing with what coal-fired power station. They have to leapfrog there in renewables and other stuff. And then other Asia coming in. This is Africa, by the way, the dark green. You know, that's enormous amount of population as well. And look how little CO2 emissions is projected there. And that is just simply because they're so poor on average. Right? So when you just have, say, a couple $1,000s a year, average GDP per capita, you don't use much energy. But could we be wrong in there? You know, with distributed solar, distributed wind, etc., could they actually develop faster and actually leapfrog there in industrial development, and actually they will put extra strain in the system? We don't know, but that gives you the dynamics of the CO2 emissions. So it's all very well, especially for the Europeans, when we say we have to reduce CO2 emissions globally, but what we really say is, please, others do that for us, right? I mean, and by the way, we don't want to pay for it, of course. That's very consistent with America as well. There. Anyway, so this scenario, things best practice, and actually it's a normal technological churn. We're not going to decommission plant earlier than its normal economic lifetime, peaking by 2030, and then actually net zero emissions by 2070. Now, net zero means that there's still emissions, and I'll come to that later when at the end of the talk where they're coming from. But you need offsets, basically to compensate for what we call the heavy-duty transport, aviation, trucking, shipping, which is very difficult to capture. Anyway, 50% reduction in 2050. Now, this scenario was made in 2017, published early 2018, and then, you know, it was Paris world was a well below 2 degree scenario, yes, tick, and if we could, a 1.5 degree scenario. And then, end of 2018, IPCC 1.5 report comes out and says, by the way, the new goal is 1.5 degrees. And actually this scenario with a lot of nature-based solutions, so basically reforestation the size of Brazil worldwide, would also become a 1.5 degrees scenario. So in that sense, we think that scenario is still reasonably robust as a kind of a projection, at least for the next 5 years. Still, of course, we see CO2 emissions going faster than it is. Right, let me go for a few key messages from this scenario. First of all, if you want a highly efficient and a low carbon system, you need to electrify that system. And that's actually the blue here on the bottom, and I'll come to that. But here is that invisible fuel, the efficiency gains. Eric already says a factor 3 has to accelerate, and actually the IEA report yesterday on energy efficiency is actually slowing down globally on efficiency. So we're going the wrong way there. But this is stuff, 40% of the solution is energy we're not going to consume. In our scenario, that means that North Americans are going to halve their energy consumption per capita by maintaining your lifestyle and your economic growth by 2050. Just think about that. It's an enormous capital investment game. Right. Then the next thing is actually, if you want to electrify your sectoral demand, because this is actually our end consumers. So this is the energies you use as an end consumer, so you lose electrons and molecules. Now these electrons at the moment is only 20% of our energy use. 80% is fossil. So how much actually electricity can you then push in these sectors called buildings, industry and transport? And I think, you know, we average at probably buildings close to 95%, industry probably 40-50% if you really do well, but there's always cement, steel, which is going to continue using anthracite coal and other high heat value solutions. And then of course transportation. Bloomberg is very much out and a fantastic projection, all electric vehicles, etc. But that's 25% of all transport. If you take aviation, trucking and shipping with it, then we think in the best case we probably can go something like 40%, 50% there in decarbonization. So the whole world will be struggling to put about just over half its emissions, by the way, either renewable electrons or biomass electrons with carbon capture and storage attached to that, to take CO2 out of the atmosphere and actually repair and overshoot where we're in now. So that is, okay, good, we need to electrify. And what does that mean? Well, first of all, you see there's an accelerated growth in energy, in electricity consumption. And that means us. Our homes have to be different, our cars have to be different, the industry has to change at a rate 3 times faster than they used to do. And that all has to go within the next 2.5 decades. And of course, to market design, that means you have to build the supply first before demand can follow. Demand, if you have a demand pool, it gets too expensive, and then consumers won't have that. Bit of a political problem to actually finance that and get it go through in the system. Besides the land use, of course, the footprint of renewables is an order of magnitude bigger than the fossil fuel industry or nuclear. And that certainly becomes an issue, even in a country like the Netherlands, where I come from, where we historically know a lot about windmills, but we have already enough windmills, and we've just started the journey. Right? It has to become probably about 20 times bigger than we got today. And already now society says, well, excuse me, this is getting a bit a lot in my backyard. Right, then so the rest is still molecules. And here the red and the pink is what we call liquid hydrocarbon fuels, which is basically crude oil and biofuels. And I say, but Eric's picture here, you saw this kind of oil demand decline. Yes, but that's not liquid hydrocarbon fuels decline, because actually it hardly declines over this period to the end of the century. The same with natural gas, being replaced by hydrogen gas and biogas. So when you look actually to our present molecular-based energy system, and from an IEC's perspective, well, this is not the end of the world, is it? I mean, okay, our own market doesn't grow anymore, but hardly any shrinks. It is, okay, our feedstock is going to be from fossil to renewables, yep. We got, 50 years time doing that, yep. Our capital churn is about, 15, 20 years in our company, then you've actually replaced all your assets. Well, that seems to be doable. If you believe you're an innovative company with enough deep pockets with a balance sheet, etc., that should be doable. Then of course is the point is, don't you want to play in this exciting new market of 50% or plus electrons? But I think people start realizing that the profit margin here is not the same as there. Because here you're basically pretty much locked into regional systems, local systems of regulators who doesn't like you have excess profits, and they get caps like we get in the UK, and then I will bleed for a year till so many small companies go bust, and they raise the cap again. So actually, this is a real big energy playing field. Right? If people think this, renewables like homegrown and small scale, that's not going to be. This will be for the big boys, big girls, and big tech, maybe I should say. There will be new incumbents there to actually play in that space. But nevertheless, from an IEC perspective, this is quite an exciting world where there's a lot of opportunity, the cards are reshuffled, and obviously we have the confidence that we have a good chance to win in that one. Just people worry about the existing industry. Maybe that's also actually a career advice one. There's still a good career in fossil industry as well while we do the energy transition. So don't forget that. Right, just to round off, back to this CO2 emissions. Where is it going to be happening? And just to do that, basically it's about 50-50. 50% is in the fuel providers, and blue is electricity, and red is the refining industry. And these are the sectoral industry, transport, and then this is buildings. And you see the relative contributions basically today. And actually, where is the reduction going to be? No surprise, of course, in electricity. When you reduce that by renewables, or when you have biomass power stations with CCS. And I'm not going to detail that, but to make a 2 degrees world, you really have to take CO2 out of the atmosphere. And the way we do this in the scenario is via the biomass loop. A lot of people think, we advocate CCS because it will prolong the hydrocarbon age, wouldn't it? Yes, but it's the biomass, the bio-hydrocarbon age, not the fossil hydrocarbon age. So, like it or not, you need CCS, at least in this scenario, to reach your goals of Paris. Then actually here you see also a lot of, say, the refining industry and aviation industry doing a lot of sequestration, and also say when they make biogas or biofuels, they can put that on the ground. Now, the industrial sector is coming down, but very, very slowly. Really more in the end of this, this period around 2015. That's because of the longevity of the assets. And our steel mills, how much is that? 40 years and other things can take a long time. The light blue is the passenger transport, and here 100% by 2030, within 10 years, I cannot buy anything else than an electric car. Sorry, no choice. Forget about it, and your gas guzzlers have to stay in the garage, and maybe in certain circuits you're allowed to play around with that. But just think about it, 2050, the whole world will have to have electric vehicles. That includes Africa, South America, Siberia, Alaska. Just think about what that challenge is, but that's the assumption. So yes, Eric already said we were much more aggressive than anyone else in, say, in electric vehicle uptake, or in solar PV uptake, or in wind uptake, but that's what's required. But then still, the purple is the heavy-duty transport. Very difficult at the moment to decarbonize. We have a hydrogen pathway for that, but that is not really starting off till 2050 for reasons I'm happy to answer later. And buildings, of course, can be decarbonized to a great extent, but that will be costly. In the Netherlands it costs about 50,000 euros, or say $55,000 per house to do that, and people say, sorry, that's a bit all the money to spend. Anyway, all to say is that our company is very much also in that decarbonization route. We really want to make traction via the sectoral approach. So we say there's certain global sectors like aviation, trucking and shipping, where there's only actually a few key incumbents, where if we get critical mass with them, right, we can actually make a start to actually in the right direction. So our company doesn't want to wait anymore for this infamous legislation and this infamous coalition of the willing of governments, right, to give us the framework and safeguards our rent models, etc. We just think it's time that industry is going to take the lead. And that is basically a very ambitious goal, but we did some workshops on that, and actually I was surprised to see how much CEOs of large companies, not only in the OECD, also in the developing world, are very keen to start taking part in that process. And well, here you see that the relative contributions, again, renewable power, biofuels, different modes of transport is very important, but also think about natural sinks. And just to give you an example, like in the EU has a very stringent target, net zero emission by 2050. Bang. Now, which country can do that? Maybe the Netherlands, 55, if they really push it hard. Denmark, of course, Norway, but Norway is not in the EU, by the way, just for correctness. But countries like Poland and Czechia, with all the coal-fired power stations, they have no hope unless you start adding their biosphere restoration. That's really what it is, these nature-based solutions. If you put that in, they can bring also their goal net zero to 2050. So it is really part of the solution, but it's not a replacement of all the other solutions. But you see still CCS is relatively modest, but that's still required as well. Anyway, we have a company of quite ambitious goals, but I'll skip that. And as this is an academic institute, people like data. All this data is on our website. You can download the whole data set. You can play with it yourself and see actually what different parts of the world needs to do, because we recognize that the world doesn't go in one speed. There's a multiple speed. You have leading economies, following economies, and then actually called lagging economies because they're basically not in the economic position to do so. And that's all nicely presented nowadays, and you can download it and play around. Okay, well that was it. That's my presentation. Oh, it's just a nice setup for the next.